Who's ready to party? Do some stoichiometry. Stoich! Complete combustion of ethene. We're gonna balance this first. Don't give us a lot of room to do it. So me copy and paste more room. All right, if you tried this problem without balancing it, you might want to try it again. Pause your video. That's actually my sound effects. Let's balance this. 2 carbons on the left, 4 hydrogens, and 2 oxygens. Over to the right side, we got 1 carbon, 2 hydrogens, and 2 oxygens from the carbon dioxide, and 1 connected to the water. Put oxygen on its each separate line because it's 2 different places there. But you probably know that by now. All right, let's balance the carbons. Multiply the carbons on the right side by 2 to balance that. Carbon, oh man, I'm going to squeeze that in there. That's a 2, goes right there. Let's update the oxygen that's connected to the carbon. So that's 2 right there. And that's going to up to 2 times 2 is 4. This is going to work out nice because updating the hydrogen is going to turn that odd number to an even number, which we need to do. So this one's going to work out nicely. All right, we need to multiply the hydrogens on the right side by 2 to get 4 hydrogens on both sides. Let's put that coefficient there where the H is. All right, also update that oxygen, which will give us a nice even number on the right side. 4 plus 2 is 6. 2 times 3 is also 6. So let's get that 3. Squeeze it in there. Now I'm going to put a 1 there just for visual purposes. There's our balanced equation. We can't do any of this correctly without a balanced equation. Stoichiometry depends on it. So let's do the stoichiometry. All right, what's the thing here? So all right, so they're giving us 2.7 moles of ethene. They give us both of these. They give us that, and looks like we're gonna have to do stoichiometry twice to figure out what the limiting reagent, limiting and excess reagent are. Bummer. Let's do it. All right, we'll do this one first. Ethene. This is not too bad. They gave us moles. We don't have to do step 1. And in fact, we don't. This is not going to take long at all because we're just comparing the two. All right, so there's many ways you could have done this. Just a heads up, but I'm just gonna try something here. I'll just start with ethene because it's right there first on the screen. 2.70 moles of ethene. Okay, and we're just gonna compare that to the moles of oxygen, and then whatever you have left over is going to be excess, and the other one's going to be the limiting. Okay, that's the concept. If you had 2.7 moles of ethene in this reaction, all right, hypothetically, let's just say, forget about what it said in the problem. Let's see how much oxygen would be needed for an exact perfect match. Okay, so that's what I'm doing. I just want to see how many moles of oxygen would be a perfect match. You could do this the other way. That might have been faster actually, but so I'm going to keep going here. What's the mole ratio? It's a 3-to-1 ratio or a 1-to-3 ratio, depending on how you're looking at it. So 3-to-1 ratio. Just check again. Yep. 3 times 7 is 21. Hold on. What are we doing? Carry the 2. 3 times 2 is 6. So it's 8.10 moles of oxygen. I'm going to need a little more room. 8.10 moles of oxygen. That would be perfect. Perfect. If we had that much oxygen and that much, it would be perfect. But it's not going to be that way. It wouldn't be a problem if it was. All right, so we're going to compare that to 6.30. I'm going to go back to the screen here. Nice. Go. What did I say? 6.30. So we're going to compare that to 6.30 moles of oxygen. So clearly, what do you think? Do we have enough oxygen or not? No. We're going to run out of oxygen before we run out of ethene, right? This is like what we calculated, but this is like what the problem gives us. So the problem gives us more than what we would like. So this is oxygen is your what we call the limiting reagent. It's going to run out first, and therefore the ethene is going to be the excess reagent. That's what's going to be left over. We identified. So let's move on to the last part of this question. Let's go with what color haven't I used? Red. All right, what's the volume of the excess left over? So it would have been faster if I started with oxygen, because I'm going to do that now. I'm going to start with the limiting reagent, okay, which is again the oxygen. The limiting reagent. All right, 6.30 moles. Now I'm just applying the same concept I did earlier, except I'm starting with the actual limiting amount of oxygen given. Now I want to see how much ethene I can make with that limiting amount. I think you see where I'm going with this. To 1 mole. All right, I just flipped that around because I need to flip it around for this conversion factor. If I had this actual amount, which is, I know that that's my limiting reagent, how much would I need the perfect amount of ethene to react with this amount of O2? All right, well, we can do this without a calculator. 3 goes into 6 2 times, and 3 goes into 3 1 time. So 2.1, excuse me, moles of ethene would be a perfect match. That would be perfect. But we have more than that, so let's subtract it off. You see, subtract it off. 2.7 is how much we really have in the problem. I'm not going to write all that out. Minus, all right, what is actually going to get used if we started with the limiting reagent. All right, so that's going to be 0.60 moles of ethene is just going to be there, like left over, wasted. It has no more oxygen to play with. It's all by itself. Oxygen, no more. What is it asking us? What is the volume? Okay. Well, these are all gases. We're going to assume STP. All right, let's just change that to volume. Conversion factor. Get rid of this. We need that same unit on the other side of the conversion factor. And volume is measured in liters. We get to choose, so we're going to use liters. Easiest unit to convert now. 22.4. All right, this one I'm going to get my calculator out. 13.44. 13.4 liters of ethene left over, excess.